When we started this series of lessons for this particular class, we mentioned that our motivation was to get to the point where we could have users that owned tasks. And so we've done a lot of work mainly around setting up the user class and making our site able to work with user objects, to register users, to log in users, to manage their session data so that they can still be logged in from one request to another, to send flash messages to those users to communicate them when they aren't able to be logged in or their registration data doesn't validate, things like that. We haven't actually in any way connected task objects to user objects. And so that is the culminating lesson here that we're going to look at today. And this will be pretty exciting to wire all this stuff up together. Okay, so the way we want to think about this is the idea of a user having many tasks. For every one user, there will be several task objects. A given task object can only be owned by one user. So this is the idea of a one-to-many relationship. And so you looked at how one-to-many relationships in the relational world can be managed by foreign keys and joins, and we'll see how that plays into the Python world using ORM and using SQL Alchemy. So ideally, just to kind of slowly move in the direction that we want to go, it would be nice if every task that I created had an owner. Okay, so in concept, I would want to be able to pass my task constructor an owner and say self.owner equals owner. And it would be super cool if that owner was an actual user object, right? And so I can actually do this. I can actually set up my constructor this way. The way I actually make this owner a user object and set up this relationship in a way that SQL Alchemy knows how to manage it is to add two additional properties, one to task and one to user. On the task class, I need to add a new column. I need to say that owner ID is a new DB column. It's going to be an integer column. And that integer is going to represent the foreign key associated with a user. Okay, so this is the syntax we use. So recall that a foreign key is a key column that links to the primary key column of another table. So on our user table, we have an ID column that has a unique ID for each user. And so by having an owner ID column on the task table, that will say a given task can have an ID in that column, and that will specify via the foreign key relationship which user owns that task. And we'll look at the actual data in a minute when we're able to create it, but that's the concept here that we're using, and this is the specific SQL Alchemy syntax that we can use to set up that relationship. On the other side, I can specify that a user has many tasks, and I can specify that in the following way. This isn't going to be a column because my user won't have a column that represents all of the tasks, but what I want to do is specify that there's a relationship here that we want our object relational mapping system, or SQL Alchemy, to manage for us so that it makes sense for a user to ask for their list of tasks. And so I can use that, do that using db.relationship. And I specify which class the relationship is to. So this relationship will be to instances of the task class. And I say that backref is equal to owner. And this basically says that you should populate, SQL Alchemy should populate this tasks list with things from the class task such that their owner property is equal to the specific user that's in consideration. Okay, so a couple things to note here. When I set all this stuff up, part of this is just getting used to the syntax. It's a little bit clunky. It's new. Reference the lesson notes as much as you need to remember that, and also the documentation on the internet for this stuff. One thing to note, though, is that we'll see how this plays out on the data side, and it'll be very similar to what you've learned about SQL in previous classes. But notice that in the Python world, owner is an object that will belong to my class, right? But will belong to a given task. But each given task in the database is not going to have an owner object, right? That's not the way relational data works. Each given task in the database will have a foreign key to the owner ID that owns that task. So there's an object relationship here at play that will be translated to a relational data relationship on the SQL side. Okay, so let's go ahead and play with this in the Python shell and see if we can kind of see how these things relate to each other before we go ahead and try to use them in our code. So I'm going to start up my Python shell, and then I'm going to say from main, as before, from main, import db task and user, because I want to use all three. Now, we've just updated both the task and user classes, and that means that since those are model objects, we need to update the database schema for those two tables. And in particular, that means via the way that we've worked with Flask, we have to drop the tables and recreate them. So let's go ahead and destroy all the tables by saying db.dropAll. Okay, and if I go and check out what happened there, I can say, let's go to here. No tables found in the database. I just trashed all my data, which is in this development setting that we're playing around with. It's totally fine. Now let's say db.createAll. And that seemingly created two tables with these given schema. Let's go here and check it out. Now I have my task and user tables once again. Our user table is not going to show anything interesting in terms of structure. It still has the same structure, ID, email, password. However, let's go to our task table and look at its structure. So we have an ID and a name and a completed. These are all three things that we added in earlier lessons. Notice that a given task, though, will also have an owner ID, and that will be a foreign key that relates it to a specific row or a specific entry in the user table, whoever the user that owns that task. So that's what that looks like in terms of the database schema. Let's go ahead and create some objects with relationships to each other and see how that plays out on the Python side too. So now I don't have any users or tasks in my database, so I need to go ahead and create some. So I'll say user equals user and recreate myself. Okay, and now I can say task equals task, and I give the task a name. And let's remind ourselves of what the task constructor looks like now. Now the task constructor takes another parameter. Aside from name, it takes an owner. I can now specify that the given user owns the task. Okay, let's go ahead and add both of these to the session. Okay, let's commit. Okay, a bunch of SQL spit out. Let's go ahead and just look at the data. It's going to give us a quicker gut instinct as to what happened. Okay, so now we're looking at the task table. I have one new task stored in the database. It has an ID of 1 because it's the first. It has the name that we gave it. It has completed flag of 0, which translates to false when we're in the Python world. And under owner ID, I now have a new entry, and that's a 1. And notice that this is linked. So phpMyAdmin is pretty smart about this stuff. It knows that this column is a foreign key column, and that it means that whatever the ID in here is, it relates it to the row with that ID in the user table. So let's go ahead and look at the user table. And when we look at the user table, we see that there's user with ID 1 with the given email and password that we supplied. And so the foreign key relates to the primary key over here. So let's do one more thing, which is to come over here and look at the task and just see that if I actually click on this owner ID, phpMyAdmin is smart enough to go show me that particular row with that primary key. Okay, so that's how these things relate to each other. So yeah, so now let's go ahead and look at how we can actually use these within our Flask application. So I'm going to kill my shell. So far we've only messed with the models. We haven't changed the code that manages tasks below. So let's go down, pass all this login and registration stuff because that doesn't really care about tasks in any way. And we'll come down to index. Index is the important one. Okay, so it's sort of in this area that we're concerned about what we want going on. So this is where this conditional is going to handle the situation when the user makes a request to the root path as a post, which means they're trying to create a new task. They've typed in something into the form, and they're trying to create a new task. And we want to basically be able to get the user and assign the task to that user. So I have task name that's in the session, or sorry, in the form that's submitted, the form data that's submitted via the post request. I would like to be able to get in this line, before I create the new task, I want to have the owner right there, and I want to be able to get the owner somehow in the line before. So how can I get the owner that I want this task to belong to? Well, we know that now our users have to log in before they can see this page. So if somebody is visiting this page, if they're on the route path where they can type in information into that form and create a new task, it means they're logged in. And if you remember how we actually logged users in, let me scroll up and show you. We log users in by putting their email in the session. So as long as a user's logged in, I know that I can get their email out of the session. So let me come down below, and I can basically say that I want to get user.query.filterBy, and filter by email equals session. Pull that email out of the session, filter by that, and get the first one. So this does a couple of things. One is it gets the email address of the current logged in user out of the session. Then I filter the user result set by that email, and then I get the first one. There should only be one since emails are unique, but I have to ask for first one, and that will put it in this owner variable. Then I can create a task with that owner. Okay, and that's literally all we need to do. Let's go back and test this and see that it actually works. Oh, looks like I haven't started my application, so we'll do that really quick. Okay, now I can log in. Okay, we see that we do have the task displayed already that we created via the Python shell. That's just fine. I can go ahead and say done. That's cool. Let's go ahead and create a new task. Okay, and now that one is displayed in the list as well. And if I go to the database, I will see, on the users table there, let me go to the task table. I will see that I have a new task with that given ID that assigns it to that owner. All right. Now one thing, let me go ahead and open a new private window and show you something else that's going on here. So in this private window, this is going to result in a different session and different login information than the other one. So this just allows me to have two different users logged in at different places within the same browser. So let me register for a new account. Okay. Now notice that when I log in here as that new user, as jack@launchcode.org, that I see Chris's tasks. I see the task of the other user. And that is because if I come back over here to the code and I look at the place at which I am querying the tasks to pass into the view, all I'm filtering by is the completion status. I'm filtering twice. I'm saying, give me the tasks that are uncompleted, and then give me the tasks that are completed. I need to add, now that I have the concept of an owner of these tasks, I need to add the additional filter of who owns them. Okay, who owns this task? So let me go ahead and come back up here and take this line where I'm querying for the owner or for the user that is currently making the request and put it above the conditional. Okay, and now I can still use that owner object within the conditional, but I can also use it down below, and I want to use it within each of these two lines in the queries in the filter bys to specify that the owner of the given task should be the owner that I'm currently working with that made this request. So just to be clear, the owner on the left, this is saying query for tasks based on the value of the owner property. And this is saying the value of the owner property should be the owner variable that exists currently within the given context. Okay, and so that really should be it. That's all we need to do. Let's come back, and now I should refresh. This should refilter, and these tasks that don't belong to Jack should go away. Okay, that seems like it worked. Let's go back here and refresh and make sure that the tasks that belong to me still remain. Okay, and so they do indeed still remain. Let's go ahead and do an additional check. Let's give Jack a task. Jack likes his walks. So I give him a task and it shows up in his list. If I come over here and refresh my list, I don't have his tasks. So just to recap what we did there to get all this functionality to finally click fully into place, we set up our model objects so that they now have a concept of a relationship to each other. That's a one-to-many relationship. For every one user, there are many tasks. Each task can only be owned by a given user. Our user now has an owner property. We initialize that in the initializer, and then we specify the relational side of this relationship, which should happen on the SQL side by specifying that our task table should have an owner ID column that's a foreign key column to the user.id column. And so the ID column on the user class will be determined or will be used to determine which tasks are related to which users. Okay. I can also access all of the given tasks for a given user directly off the user object if I wanted to. We didn't see an example of that, but this specifies the inverse relationship. This will allow me to get the tasks off a given user object using .tasks as well. Okay. Yeah, so that's it. So that was pretty cool. We did a lot of work over the last few lessons, and then it all kind of magically clicked into place with a few steps at the end. Pretty cool, huh? I think it's great. This is super useful. You can do a lot with the things we've just learned in the last 2 or 3 classes. And you indeed will in upcoming problem sets as you use this to build a blog with users that own their own posts. All right, thanks for coding, and we'll see you next time.